So today we're going to be talking about how you solve for variables. And so if you look here on the board, we're going to go ahead and start with this. It says to solve for m. So basically what that means is I want to get m all by itself. Okay? So the very first thing, okay, that I'm going to do is I'm going to go ahead and compare this to what I have here on the board. Because what we're going to be doing is here on the second equation. Okay, what I've done before in the past is I've solved 4m minus 3 equals 8. What I'm going to do now is solve 4m minus 3n equals 8. So what we're going to do is we're going to work these side by side. So on that first equation, what would you do?
Add 3.
You'd add 3, right? So I'm going to go ahead and add 3 to both sides. So I end up getting 4m to equal 11. So over here, I'm going to do the same thing, except for instead of adding 3, what am I going to add?
3n.
3n. Now, when I add 8 and 3n, those are not like terms. Those are not like terms. So since they're not like terms, you leave that 8 plus 3n. Okay? You don't add them. You don't get 11n. You don't get 11. So what do I do on the next one? What's the next step I do? Divide by 4. So what do I get m to equal? 11/4, right? We could just leave it 11/4. So what am I going to do over here? Divide by 4, same thing. Now, over here on the right side, I can't divide each of those by 4. So my answer is just 8 plus 3n. All over 4. And there you go. So it's along the same lines as what you've been doing. Some people think these are harder just because they've got multiple variables. I think they're easier because you don't have to worry about adding and dividing things. So let's go and look at another one. Okay. 3n plus 6p. And we're going to solve that for n. So I'm going to get this baby all by itself. So what's the first step?
Subtract 6p.
Subtract 6p. Very good. Okay, so I'm going to subtract 6p from both sides. On the left, what are you left with?
3n.
3n. On the right, what do you have? 15 minus 6p, very good. What do you do now? Divide by 3. So here's what I get, 15 minus 6p all over 3. But I'm going to tell you right now, that's not my final answer. Because if I look at all 3 of these numbers, are they all divisible by some number? What are they all divisible by? 3. Now you have to check all the numbers. Okay, and they're all divisible by 3, so what I can do is divide each of them by 3. So what is 15 divided by 3? 6 divided by 3? 2. 3 divided by 3? 1, so really my answer will just be 5 minus 2p.
So you just like reduce it?
Yeah. Now this is the thing though, you have to reduce all the terms. It can't be like 2 of the 3. Like the previous example, you look at 8, 3, and 4. Okay? The numbers have to divide into all 3. Notice 4 goes into both 4 and 8, but it doesn't go into 3, so that's why we couldn't reduce that one. Okay? All right, let's look at another one. This one's a little weird, but it's not tough at all. K minus 2 over 5 equals 11j. And so our task today is to go over a lot of these so that you know what to do in about every case. And our goal here is to solve it for k. So what do you think the first thing to do is?
Times both by 5.
Times both sides by 5. That's exactly right. I want to get rid of this 5, and I can't get rid of the 2 until I get rid of the 5. So I'm going to multiply both sides by 5. Now on the left, what ends up happening is your 5's cancel, and it leaves you with k minus 2. On the right, you have 11j times 5. What's 11j times 5? 55j. What do you need to do now to solve? Add 2. Very good. So what's your final answer going to be? 55j plus 2. Now remember, we don't add the 2 with the 55j because they are not like terms. So far, so good? Have you guys done these before? Okay. All right, let's look at this one. Now there's 2 ways to do this one. Okay. There's the easy way from the get-go, and then there's the way that takes a little longer. I'm going to show you the easy way from the get-go. All right. I want to solve it for t. I want to get t all by itself. So if you notice, I've got t times the quantity r plus 4. What undoes times? What undoes times? Or multiplication? Division, right? So if I take t times that whole quantity, to undo it, I'm just going to divide by that whole quantity. Since it's a quantity, you can do that. So whatever I do to one side, I got to do to the other. So what do I have on the left side? Yep, and that's going to equal t, because those have canceled. Those are gone. So see, that problem was actually really easy if you could recognize from the beginning that all you do is divide. Yeah?
So then would you divide by 4?
Okay, remember what we said, you've got to divide all 3. So the number in front of r, right here, would also have to be divisible by 4 in order for you to reduce. All right, let's look at this one. A times n minus 8 equals 23. Now this one's a little different because we're not solving it for A, we're not solving it for the one outside the parentheses. So what do you think we're going to do on this one? First step. Multiply what? You're right. Distribute. Basically, I'm going to multiply this A. So here I get AN minus what? Equals 23. Now, remember, I want to solve this for n. I want to get the n all by itself. So what are you going to do first? Add 8a. So what do you have on the left side? AN equals, yep, plus 8a. What are you going to do now? Divide by a, yep. So on the left side, those are going to cancel. It's going to leave you with n equals 23 plus 8a, all divided by a. Now, can you cancel an a out? No, because it is not in all 3. Remember, in order for you to cancel anything out, it has to be in all 3. Alrighty. Ooh, this is a doozy. Because what do you notice? You're having to solve it for what? X. And what do you notice here? There's 2 of them. So then the question is, what do you do? So what we need to do is get all the x's to one side, and we need to get everything else to the other. So I'm going to go ahead and move the xz to the left. So on the left I get 3x minus xz minus 2y. Now what do you have to move? The 2y. So I'm going to add 2y to both sides. So I end up getting 3x minus xz equals 5 plus 2y. Now, this is one of the things, each of those has an x, right? So I'm actually going to apply the distributive property in reverse. And this is going to look a little weird, but I'm going to take an x out. Now, if I take an x from the 3, x, what does that leave me with? If I take an x from the 3x, what does that leave me with? 3, right? If you take an x from the xz, what does that leave me with? So, yeah, so 3 minus z. So basically, I just took those out. I actually applied the distributive property in reverse. Because if I distribute this x, I get the same thing. On the right side, I have 5 plus 2y. So what do I need to do now to solve? Remember, this is just like that really easy one I showed you. Divide by. I want to solve it for x. Divide by 3 minus z, because I want to get the x all by itself. So your answer will be x equals 5 plus 2y divided by 3 minus z. Okay, I'm running out of time, all right, which we actually got through quite a bit. So, what we're going to do right now is I'm going to go ahead and give you this. This is your assignment, page 129. 8 through 15 off, 16 through 22 to evens, and let me look real quick, 24 through 27 all. Okay, actually what I'm going to do, just for sake of time, we didn't get numbers 26 looked at, so I'm going to change that. There you go. Okay, page 129, 8 through 15 all, 16 through 22, the evens.